talked about arrays of characters, which is also strings of characters. And partially some of the program that I did last week, I have included on this assignment, as well as wrote new programs for you and new kind of displays that you are going to try at the lab activity. So it's all ready for you to just learn more on it. And let me make sure that this is all shared. Yeah. So the week 15 is shared. I'm going to move this one right at the corner here. And then on week, this week, week 18, we're going to discuss strings and vectors. First, let's discuss strings. There are two types of strings. One is the C type strings. The C string is a module that is called a C string itself. And there are predefined functions that we use: a string copy, a string cat, a string encopy. All of these ones are explained here on the display 8.1. So now on the C string, this is like a C style of when C++ doesn't exist on the C. Every time we used a program to just manipulate the strings, we use the C string. So the C programming language, we use string.h or strings.h. String.h is a header file that was included on it, and then C string is another module that actually on C++, C string is doing all the things that we used to do on C programming. So it is called C string because the style is still the format of the C style string. In these predefined function like a string copy, a string encopy, a string cat, a string encat, a string length, a string compare, and so on. All of those ones, you can see that on this table, I basically wrote exactly the details of what you need, which was also on your book. And it is partially included here, the textbook Problem Solving with C++ by Walter Savage. So this is a very good book on chapter 8 of the book. It talks about display 8.1, about the C type or C string module. The C string module is different than the string module itself. Later on, I will introduce you to the C++ string module that was kind of an enhancement of the C string. So with some kind of limitation that are on a C string or not limited at all on a string module of C++. For example, on the C string, you have to, whatever string you put, every string has a null terminator at the end of it. So if your string is cat, C-A-T, then there's a \0 null terminator at the end of that string. And that means that the actual string is 3 characters, C-A-T, but when you are storing it, the C string is storing it as 4 characters, C-A-T, and then a null pointer, which is the 0. But the length is actually 3 characters. So don't get confused with the string length being the same size. The null pointer does not get counted with the length at the time that when you do string length. And C programming languages or C string module, you have this string length. A string length, it returns whatever is your source string, it returns the length of it. For example, in this case, a source is 3 characters, a string is 6 characters. So the string length, if you call this one, this should return 9 because there's 9 characters. But at the end of the G, there's a /0, a null pointer, and that is the terminator. It's like this /0. that is not counted in the length, as you can see here. The null character is not counted in the length. So then don't get confused that this string, if it is 9, it will just add that one. And C++, a string method, this is already assumed, as if there's already written there. It does not need it to write it. It does not need to define it. It just knows that you don't need to add it. And then when you get the size, and instead of a string on that function, there's a size method that we could call it. And then the reason I said method, because these are modules. Modules has member function, and those member functions are equal to a method in object-oriented programming. In functional programming, we call it function, and object-oriented programming, we call it method. So a data structure for example, on C programming language, we used to write the data structure with struct. And then now that struct is a class in object-oriented. And the same thing, a function that you write, whether inside a struct or in a standalone function, a function is called a function in functional programming. And then on object-oriented programming, a function is called a method. And then these objects that you're using within a class, those are instances of a class, or instance of a library, or instance of a module. So module, library, and library, module, and class are just the same names, and you can use it interchangeably. But an object in an instance is the same thing. And a method and a function is almost the same thing, but in remote procedure calls or functional programming, you call it function, and object-oriented programming, you call it method. So let's just come back here on this top level here first, before we just jump into string functions. On chapter 8, we're going to discuss strings of array of strings first. And we're going to compare the equal sign with the equality signs on the C strings, and then also other functions in C strings. So this is an assignment, and this is equality signs. And then the same concept is true in C and C++ programming. When you're doing a comparison between two variables, or two different numbers, or two different integers, or float, or a string, you're using the equality symbol. But when you're just assignment the statement, you're using equal sign. We're going to do a lot of these C string functions with examples here. Similarly, we are going to do a lot of the string functions. So you're going to learn two modules. One of them is C string, and the other module is a string. So this is C string, is a C style. That's why it's called C, and then a space is string, or C dash string. But the actual module name is, you're going to put it between pound include C string. You're putting it with C and then a string like this. No dash, no space there. This is the actual module name. This is actual file in the user include directory, or if you're using, let's say, for example, Visual Studio Code or Code Blocks or some other IDE that you're using, you can actually click on this, right click on it and say, go to document and look at the content of it. Tonight, I will actually show you both of them on different platform, whether it's Windows or Linux, to see that these modules or how the compilers, when they come with these library, they call it library or module or class, well, how they are saved into different platform differently. And then what are the content of them. And then when we use, for example, a string copy, we need to include this one. And then the nice thing about C string, They are also part of the standard lib C and other C IO stream or standard IO stream. A lot of those predefined functions, sometimes you don't even need to include C string and you could use them. But if you just use a string length and it says a string length was not found, then you know that you need to do a pound include C string. And then that way it is there. So I'm going to jump in a few minutes from now onto that one to show you exactly, but let me just see, like here we are talking about copy, paste, and C string, how you could use that string copy to copy it. And then similarly, if we do concatenation, a string cat would be the command. If we are doing it on the string module, and then there's assignment operators that you can use the plus equal operator. We call it in object-oriented programming operator overloading. So in our operator overloading concept is that in addition to just write an operator plus equal sign as adding two numbers, then you can add two strings. So the data type of the variables are different. Now you're doing an operator overloading because the same operator does multiple different things depending on the concept, the variables passed on to the operator. So in that case, for example, the cout double less than sign, when you're doing a floating point or a string, or it already does operator overloading with that function. And the same thing with cn double greater sign, the extraction. The insertion for cout operator, if you're passing a floating point or a string or number, automatically does overloading. That object cout, it knows that, okay, and now I'm reading a operator and I mean variable that is a double or integer or something. Similarly, like if you were working on a printf statement or C, you would pass on %s to say that now I'm passing a string, and then %d to pass on a digit or number, %f to get a floating point numbers. So the concept of like the same function, whether it's printf or scanf or cout or cn, all of those ones are just having a multiple mechanism to just react differently at different time. So that is also called like sometimes a function overloading that we wrote the swap program. The swap program, for example, if you pass on two integer, it swap between two integers. And if you swap 10 different numbers, then it swaps 10 different numbers. Same thing with sort, or if you pass in two numbers, it's sorts between two numbers. But then what if you did not change the number of arguments? You may change the number of the type of arguments. So one time you pass in a float, the other time you pass in a string. So this is what operator overloading or functional overloading is about. A function that takes different parameters, or the number of parameters, data type is different, that's a function overloading. An operator that carry on multiple different statement. For example, a plus symbol, if I say x plus y, and x and y are two variable, then obviously the variable numbers or integer, it will just do the multiplication of plus the addition of two numbers. If I'm just doing it to a string, now it is concatenating to a string. So the plus, instead of adding the string, it concatenate. It concatenate meaning it put the end of it, the new string, rather than just putting it together like 2 and 2. If you add them, it becomes 4. But if you just put two a string with two a string together, it puts 22. You don't want to put 22. You want to just concatenate them, meaning that whatever the strings are, if you're just converting alpha to integer, then you add them, yes, it will just put 4. But if you're concatenating it, then it treat them as a string. So instead of putting it 4, it's going to just put it to 22. And then if you say hello plus a word, then it's going to say hello world, or hello Wahid, and it's going to just say hello Wahid. So those kind of concept is going to be discussed as well. And then we're going to talk about like get line variables. The method get line is going to read a line at a time depending on how many arguments are passed to the get line. Sometimes you can pass 2, sometimes you can pass 3, and when is it time to pass 2, or when you call let with 3 arguments, it's your choice, and we will discuss those as well. And then we will also finish chapter 8 with vectors. I'm going to show you a lot of different examples with vectors, a string and C strings this week and next week. And your job is only to finish, learn it, and practice it at the lab times. So there's no assignment for chapter 8. But your job is to work on your lab activity to finish out the last assignment this week, and then whatever time allows you start from December 1st to December 12th to finish your final project. Please don't submit your final project assuming that you could re-correct it and do it after the 12th. After the 12th, whatever was submitted, that's the last assignment and last project that will be graded, and there will be no update on the grades. Sorry about that, because it would be too late. And it would be unfair for all of you guys to just work so hard and submit it on time. And then we may want to make sure that we're fair to everybody. So tonight we're going to have some lab activity that is on page 471 and 472. There's 55 lines. You're going to type in display 8.2 there, and then also display 8.3. This one is about 39 lines. So 39 lines, 55 is not even 100 lines. You could do it within half an hour, really easily type it in and compile it, test it. And if you have question, please ask me question at the lab times. And if you have question on the assignment, ask me question on the assignment at the lab time as well. So let me go to tonight discussion. Last week, we actually demoed these ones. So I included the cat -n actually displays in numbers. So the program doesn't have these numbers on it. When you do cat concatenate and the demo 5.c++ program with -n option, it puts numbers in there, as you know. This is Linux and Unix and Mac. You can do these at the command line. So we're looking at the content of demo 5.c++. It has include IO stream and then include C string. So in this case, we're including C string. And then the reason we're doing it because there are certain parameters that we are passing on as a function here on this program, and we need to do it. So in this case, I created a character called like a string of character called first name. First name, notice the size of it, I just left it empty. So because I initialize it to this string, Wahidullah, that string is 10 characters. So the size of this one, if I put 10, it would still hold it, but then there's a null terminator at this. So it would be like 11 characters long. But that and the /0 is assumed. So here, when I do, I don't actually write h and then /0 inside this one when you initialize it. It is assumed that it knows that this is 10 character long, and then the end of it is null terminator. But if I just had this one to 5, Wahid, like my short name for first name, then it would be 5 characters because this one is empty. The fact that you leave it empty, you say, depending on the input here that it is there, you are going to allocate a number of bytes. A number of bytes, a character is 1 byte. But if this one is 10 times 1, the storage will be 10 bytes long. Whatever is the size of the length of the string, that much bytes needs to be allocated in memory to store this string Wahidullah. So in this case, it's asking like a cout console, please enter your name. Notice the insertion operator for cout, we're using a string here. So if I was just saying 5 here, and instead of that, please enter your name, this insertion operator would have been passing in a number 5. That means that operator can be overloaded. So depending on the variable that are coming here or manipulated here. Like here you see count plus equal 1. This means this variable count is an integer. So I'm doing a multiplication of count plus 1. So it would be count is equal count plus 1. We will discuss details of operator overloading if you have question on it. Because right now I'm trying to make sure that we have enough time for all the string and C string and vector for tonight. Let's just go back here. And at this time, so the count is equal 0. And then here I try to just say whatever the size of the file name is, just give me the size here and then go through the count. And notice, because I'm using the C string, the size of is going to give me the size of this. It should be actually size of for this one and then size for the vector. So different functions, it may just have returned different things. You're welcome to write a user-defined kind of functions yourself if you are kind of like not sure, you don't want to look up in the C string or string or some other IO stream or vector or some other module to say whether it was size or length or size of or something else. If you just kind of got confused a little bit about it, there's way that you can figure it out. And or just look it up on the documentation or look it up on the header files that itself. For example, let me just start off here, Visual Studio Code, and I'll show you on both platform, as well as I'm going to start off Linux, so you can see the effect of it, to see how you could find out the documentation for different things at different time. So let me log into my Linux server here. This one will log me in on the Linux server. Okay. So this is the Linux server I'm logged on, and as you know, this is Ubuntu. If I look at uname-a cat etc os-release, this one is Linux Mint 19.3 and is Ubuntu distribution. So at this time, if I want to just know some of the libraries that we were talking about, and Unix and Linux, this user include has all those include. The fact that we say pound include standard IO.h, for users, there's a lot of include files. For user lib, and there's a lot of include files. So a lot of the libraries are under user lab also. So depending on the system, like user include, this is all user defined. So if I go clear my screen here, do a PWD, and then I do a ls, notice there's a lot of header files.h here, right? There's like error.h, error number.h, and standard.io.h, and cpio.h, and so on. So there's a lot of them, like for example, zlib.h and c standard lib.h, and so on. If you go, for example, on this directory, and you say, let me find out the file called ctype.h. If you type ctype.h, there's no ctype.h, or there is one, that's great. I'm talking about cstring.h. cstring.h, if you do the cstring.h, it is not there. Maybe there's cstring. If that is not there, now you say, well, where is that one? So let's do this. Let's say find dot minus name, and then type in cstring, and then a star, and then this just will find you that, say, okay, there's a library called cstring. So even if I did not put a dot, because this is a C++ library. So inside here, and this is under the C++ version 7, and the actual name is cstring.h. So if I just want to say, find this one, and then let's just do -exec, and then cat that file, cut with line numbers. And so I found it, and now I'm going to display it on my screen, and then we can even do a 5 more or something if we want to just do that. But the file, let's see, yeah, the file is 123 characters. I mean, well, 123 lines. You can see it is just the header information and all the other includes that are there. It is using the string.h, which is included, and then all of these functions that are member functions of it. A string copy is there, a string compare is there, a string cat is there, a string length is there. All of them are just, if it is undefined, then later on define it, and then using the string copy and all those other modules and there. But these libraries, when you're looking for it, let's just look for the C string. I'm sorry, not the C string. We look at the string.h, and then string.h is also there. I'm gonna do the listing first and see that is there. And if I just say, well, there's so many of them, I could just say -exec and ls -l. Show me each one of them by long listing of them. So I can see that there. And if I just say, well, I have, this is the one that I'm looking for, and then that's under C++, I can cd to the C++ here, and then, I'm sorry, lowercase c++, and then look at the version, in this case is 7. 7.5 is also symbolic linked to 7, so that's the right and there. Here, string is there, C string is there, vector is there. So a lot of these modules are there. So if I look at the content word count on a vector module, you can see that it's 81 lines. I could do a cat -n vector to look at it and 5 more, so I can stop at one screen at a time. No such file. I type it Victor wrong. Victor is my best friend. I should not type that one wrong. So Victor, and then you can see here that we are reading the content of it there. But notice that on the Victor header library, we're including these other libraries under the bits directory. There's so many other libraries. The fact that this one is 81 lines, that doesn't mean that you're going to be done with 81 lines, and if something was not defined here for size of or something, it is here. So it could be like under the bits, there's other subdirectories, other header files. And then each one of them, or like you see standard libraries, and then the number. So if I'm looking, for example, on here, I could say find dot minus name, and then search for IO stream. And then IO stream is there, but if I want to do a minus exec and find out how many lines are there in this one, you can see that there's 79 lines on this one, but the actual library, when you include it, because it has this content of, let's say I go here, say more IO stream, it is just including other libraries. You see this extern for the CN, whenever we are using that, the CN is an object of iStream module. So when you're using CN on the IO stream, automatically include this iStream object. And then when you're using cout, automatically use OStream. For cerror, for clogs, everything, it uses these classes of or modules or libraries that are there in addition to the IO stream. So when I do the IO stream, it also includes these other ones as well, like OStream, and then. So if you look at the more iStream, for example, that one is there too. And this one is a little bit longer. So if I do a word count on this one, 993. And then for the out stream, it is 695. And a lot of the functions that we are doing it is just defined somewhere. So think about this. If I just do find dot minus name star, actually minus type F, this shows me all the regular files. So if I just do this one, it will show me every file that is on this directory structure under the 7. But then I say minus name, I'm going to put everything, doesn't matter what the name is. So at this time, I'm going to say minus exec, and then grep minus il, and I'm going to just say, let's say, for example, string copy. The string copy, I want to see that function, what libraries are referencing this string copy. So if you could see a list of these ones, it is going to say, oh, it was referenced on C string. Because on this path, the C string is there. Now I say, yeah, it is nice, but now show me actual string that was used in there. So the actual string is this. Now watch, if I go one level up here, actually 2 level up, because the library that this one is defined is inside the C string. And so if I just do the same command with the minus il, now it's going to just also include more files, especially the C string. The C string is using it, and then other ones like here, C string is using it, and then all of these. Now, if I just take the I out, say don't just list, take the list out, don't list the file name, only do a grep with ignore the case sensitivity of it, then it's going to just do the string copy wherever, whichever function, call it, use it, define it, it's all there. How the string copies do. The same thing if I do it with the string length, the string length. So the documentation, you could just help yourself much faster by knowing a few operating system commands and look at it. Similarly, if I'm interested on vector, like for example, let's say something that, anything that has vector, the vector is the name of the module. You can see that these are all used. Similarly with namespace and so on. So the list is on and on, but depending on what I'm looking for, and then if I'm looking for something like size of, that function and whether it is defined. And if I'm interested only in C++, obviously, I go one level down here and say C++, then 7, and then run my command here. Same command here for size of, and then the list is a little bit smaller, but let's just look up for the file names, and then those are the file names, the one that are used there. And then if I'm only interested in the function name called vector something, so I could do vector here and there, and then it will just list those ones. And now since it's these ones that are used, if let's say if it, the size of or making sense here, you could just read it from here. So enumerator data type is defined, and then size of is passed as an argument, and to get the bits type. But these are some of the things that you will later on be interested in your data structure class, or some C++ advanced class that you say, okay, I define these pointers or abstract or class or some kind of vector that I'm manipulating some data, but I don't understand the concept of how the arguments are passed. So let me, by saying that one, it actually gave me an idea to show you something here. On Unix, I told you that manual pages, let me clear the screen. On manual pages has sections. So section 3, for example, -S section 3, it shows you the header files and include files and functions that are predefined in libraries. For example, a string is one of them, right? So a string is a library that has a string copy in other ones. So whether I type in a string copy here to get the man pages, I get some information about synopsis. And then right here, you can see the way the function string copy is prototype. This is the function declaration. Every time you write a function in C, you write a prototype for it. The prototype or function declaration tells you that this string copy can be used two ways, okay? One is that it returns a character, a string pointer character, and then the source is, this is like where the destination string is going to be. So whatever the source destination is, it is going to be copied to be placed onto destination. And then that information that I put on this lab modules here. So for a string copy, you say target string and var string. We're not giving the details of how this actually defined here, string copy. If you look at this versus this does not say a return type of it. It just as if you're making a call to a functions. This is a function call. This is a prototype. The prototype is actually forces the function call to say that what argument and what parameter passes to me. So if the string character, a string copy is defined in the documentation of manual pages as this, saying that, okay, once you are having it, you have a source, a string that is going to be a constant. This is going to be a read-only constant of strings. This cannot be overwritten. That's why this constant parameters is in the prototype. So it's a char of pointer to a source string, but it is a constant, which means it's read-only. This part is read-only. This is not constant, so that is the destination string. We want to copy the source to the destination. Notice the data type of the source and the constant, both of them char star this and char star source. They are same data type. So, and then the return type is also char star. So the return on the string that is returning is that. If this one was a string 1 and a string 2, content was hello, now hello will be copied into the string 1. The string 1, assuming whatever the size of it was there, then it would just be either overwritten or just added to the end of it. And so there's a string concatenation also there, but a string n copy, this n is the limit. So right here we did the string n copy. The n is the limit here, the size t, or the size, this one is in number. Size t, whatever is the size of it, the string, and then it's going to be a number, you pass it on. If you want to copy 5 characters from the source to the destination, you put an n is equal 5, or just put 5 there. Because this is the parameter size t, n, and then as a variable, a size integer, you pass on a number. And then that number of characters from the source will be copied to the destination. Similarly with the string concatenation, it takes the source string and puts it into the target string. So if a string had high, and then the second string, the target string already had high, and then the source string had Wahid, for example, and then it will just be a string concatenation. Now on the target string would be high Wahid, assuming that you have a space, and assuming you have enough a number of characters on the target to hold both the strings. And then right here it says, and this is a problem because this one does not check for the target string to have a size or not. So instead of using this, then you use the limit with the number. So notice that this one, if I go back here, I did it show you on the string statement. And then here, the nice thing about manual pages is sometimes it gives you like a kind of like a syntax with arguments and everything as an example. It shows you examples also. And then the C also section, it tells you that other related commands like a string copy, a string cat, a string duplicate, a string mem copy, and so on. Anything that are similar, it will show you a related one. So let's look at the man minus S3 and then a string concatenation. And notice that the string concatenation also has similar two prototype. Source gets to concatenate to the destination. They're both pointers to a string character char data type. And then the second prototype has a string n, which is a number is concatenated. So depending on the size of it, if there's enough kind of bytes allocated on the destination folder on the size, obviously when you create the destination string, you allocate enough bytes in order to do it. But this is a limitation problem. These kind of C string data type that we're discussing on this module, all of these ones have limited kind of functionality. You as a programmer rather use a string and C++, the new module, which is called a string. And I'll show you the example of that one as well. So that one give you with less kind of limitation. There's no limitation. In fact, it will just do a lot of things much better and much easier, much robust. That's why there's a topic on the book also. They talk about robust, I believe, that they meant by a C string and by a string, and that are just there. I didn't read that section of it because a lot of the things on the book I already kind of like, yeah, I know that, I know that. So sometimes you can get a glance at it and you know what is another programmer or another person writing a book is discussing. But these documentation, I have gone for so many years and details on the Unix and Linux platforms. I have read a lot of it and I have understand a lot of it, and I have programmed in the environment. I have done a lot of work on these things. And then with OpenSSL, with configuration of web servers and, you know, script writing and Python programming, Java, C++, and everything else, make modules and other utilities. And then working on the, actually on the supercomputing environment. And there's a lot of these things, or just, yeah, we do this one in the cloud, we do it on the remote servers, we do it on some web servers, we do it this, but then when you're dealing with scientific data, you're working with bigger data in terms of, we call it big data, then data mining and all those concepts. The idea of data science and this and that, everything is just another term. But the actual functionality and actual usage of every programming language, the terminology comes together. And you say that, oh, this is what I mean by, doing this. For example, let's say the same modules like we did here. If I just type in man string, notice that a string itself, it shows, because the module, it shows all the predefined functions that are there: string copy, string case compare, string cat, string char, string and so on. All of that one are there, right? So you can just get information from this there. And then also in addition to that one, for example, if you just say, what does a string token do? Well, a string TOK, for example, man string. I said, what does a string token do? A string token extract tokens from the strings, but it is called a string TOK. And so there's a lot of things. What is a string do? The one string within the other string. There's a lot of different things that you can just get it from the manual pages. And if you are not familiar with it, obviously you can come in on C++ and use it, some of this through this. For example, on regular expression. Regular expression is very big things for doing kind of scientific programming, as well as pattern matching, as well as different things on the web that you can just read certain data and then parse it. For data science, you could do regular expression. For scientific, like Python, there's actually a module called regular expression. And then there's module for NumPy for doing scientific calculation. So all of these tools come together at some point. If I go back to Visual Studio here, let me just open up a new library here. And I'm just gonna write it, say, save as, let's call it C string, the C++. I'm not gonna call it C string itself. I'm gonna say my C string. So my C string, I'm gonna type it uppercase C and then uppercase string, and then that's good enough for it. Or I could just say my underscore C string. That would be also, whether you do comma face or C style, this is a C style naming. So I'm going to do that and then save this one. Now I'm going to say pound include. So I'm going to include IO stream first. And then another one I'm going to include is pound include C string. So if I include the C string itself, I can say on the Visual Studio Code, I could just, let me save this one first, this the information. So at this time I saved it, and then I'm going to just say, go to definition by the C string. So when you do that, go to definition, sorry. I think I closed it. Let me just close the other one. Okay, so the one with I call it my C string. See what file open, and then my C string. I think I call it my C string. This one. So I open that one and then has these two lines. If I right click on it, say go to definition, and go to definition, it will just open up as if I was inside that directory and I was doing what I did show you earlier with Unix commands, C string. So on Windows, it makes it much easier. By a few clicks, you can find it. But then now you have to search for one string, and then if you want to do it in thousands of files with different syntax and parameterize it and pick up certain parameters, then when it comes to the power of shell scripting, so you can just look for what you're looking for and then find what you find on that information. Whatever you need to find it, you will find it. So this one, as you can see, it is similar to what we had in there. And then you can see the path to the this function. It is exactly the same thing with both prototype. I mean, both platforms. It is this one is version 8.10, but similarly, it is not maybe exactly the same because sometimes these libraries are different based on the processor that they run, based on the compiler, the version that they run there. But look at this one. It says code block MingGW libc. So if I go to the MingGW directory of my code blocks under the lib directory for GCC, and then all the subdirectory, eventually I'll find out the include and then C++. Inside there, there's the rest of them. So I can use operating system commands like Windows command like more type and this and that, fine, to just do the same thing that I was doing on Unix. But if you're familiar with something that you can get this information from the command line, then or doing it from the by clicking a few buttons, don't bother just writing it in command line. So right here, like IO stream, if I right click on IO stream and say go to definition, notice that this IO stream is a lot more. Yeah, maybe it is here showing a lot less, a number, 80 lines, but when I include it on my include, remember when I was compiling it with save.tim files, the intermediate files.i file for your program has the actual IO stream being included. It is basically get a copy of this module and puts it into the intermediate file. So the preprocessor, when you use the include statement here, the include statement, this is a directive called include. It just gets this library and extract it and puts it into your intermediate file at the time that the preprocessor compiles your code. Once the linking is done, all these functions that you're using inside CN and Cout, the definition of those ones also gets copied to your executable with the linker. So it gets there attached to it. But without those ones, if we just use Cout or CN, it's not going to find it. So now let's say we write function here, say, I'm not going to do using at this time. I'm going to try to say, what if I don't use the namespace? Can I just use the string module and C string modules without that? So I'm going to say int main and then see what else we need besides just including this. And even if I just put this one 2 slashes, say don't include it yet, let's just call it and say that I'm going to declare a character array, and then I'm not going to give the size here. I'm going to just say character array, but then the string is going to be actually cat. So if I just do that cat as the string here, and then I have to give the name of array here. So I'm going to just say my cat, and then let's just call it my first cat name. In this case, I'm going to call it I call my cat Mausa. Hope whatever, we lost this cat a long time ago, and I hope he's still alive. So Mausa, I'm going to do Mausa 2Z. And then the next one, I'm going to say character my cat 2. So let's just call it this one my cat 1 and this my cat 2. And this one, I'm going to also not define it, but then I'm going to create a character array of it. In this case, I'm going to say Simba. So S there, and then I and there, and then M there, and then B there, and then A there. And then since this is kind of character, it's assumed that this one is actually having a null pointer character as well. Notice this one was a string of it. This one is assumed already that there's a null pointer character here. This other one's my cat 2 is just having the same kind of name. I mean, sorry, the names are different, two different names, two different instances of cat. One is called Mausa, the other one is called Simba. So at this point, I need to change this chat to char for character type. So that error goes away. And then now my syntax is good for declaring two string character of array. One has initialized to a variable Mausa, and the other one is called Simba. So now let's print it out for this one. So if I just say for actually do C out before any for statement, we just say C out my cat 1, and then at this time we're going to just print it out, and then we are going to say string length of my cat 1, and then just do this and the end line. And notice that the inline and then the string length and C out, all of them are not going to work because I did not put standard n colon colon. So in front of each one of these, I need a string standard n colon colon in order for this error to go away. Similarly for this C out, I could say standard n colon colon, and then that C out goes away. So notice that these will go away, and then similarly the string standard n colon colon. So this goes away. You can see that this string now is going to just go away. But if it doesn't go away, it's because of this library and this function is used within this C string. So then it means that I have to uncomment that one in order for the string to just be understood. Now string length is defined within the C string. It just went away, it understood it. So now if I did this one, similarly, I want to do the same thing because I did not using name. So I did a standard library name. Otherwise I could have done using namespace. So I'm going to just change this one to cat2. And then this is cat2. We want to print it string length, and then here we're going to just say, since we said int main, we're going to just say return 0, meaning successful if this function does not fail, and get rid of it and get rid of line 13 because it's blank line. So now we have this, and then let's save it and compile it. Okay, so the output is good, but we need a little bit of space in between them. So Mausa is 5 characters and Simba is also 5 characters. Let's just put some space in between here, or maybe tab it and then one tab in between them. So tab is a single character, so you could do a single quote or double quote within the cout, it will interpret it correctly. But if it is a single character, you better have a practice of using a single character with single quote. The reason is that sometimes you use get line, and get line requires the single character like /ln to just be printed as a single line, not double quote. When you double quote it, it means it's a string. A string is different than a character. Even a character with one letter, it is different than a character, a string that is one letter. So now we should have a different output in Mausa 5 and Simba 5. Notice that in this way, we are defining kind of a string of C type, C string, that has this kind of information with this data structure or this array of strings. So if I just want to print, like let's say I'm going to only print on both of them, let's say the fifth element, the last element. So let's say std : cout, and we say the last element of the string or strings, or so we're going to not just put a string 1 and a string 2 and so on. We assume that we already know what we're talking about here, just for faster demonstration purpose. So cout here, and we're going to say std and then cout, and then this time I'm going to do my cat, and then if I just put 5, that would be out of bound range. If I put 4, then it will just put on the last 4. And then the same thing if I put, I'm sorry, my cat 1. That's why that is a red color, because my cat is defined, but my cat 1 is not defined. So if I do my cat 2, and then put, because there's 4 characters, so 0 would be M, and then A would be in the my cat sub 1. I mean 4 would be my cat sub A would be the result of it printed out. So here we are going to just save it and run it. Okay, so what happened here? Mausa symbol. Oh, the inline, it was not understood, so it did not compile it because of forgetting the cout, and then save again. Okay, I see there's 9 people. That's good thing. I'm going to just quickly fix this one. Who else showed up? Alec, you showed up, and who else? Let me see who. Christian was here already, I believe. Ruth, Siemens, Whitney. Beside Alec, who else joined in?
I did, Professor. Christian.
Christian, okay, yeah. Thank you. I thought you were there. So let me just correct the attendance sheet quickly. Grades, attendance, where is it? This sheet always disappears from my eyes. Maybe I don't need to track on people. I don't do that. Just for your own good, we have to put it on the syllabus at the end of the semester that when was the student last attended. So here, Christian and Alec, I'm going to mark them present. Christian is here. and then Alec is here. Thank you, guys. And if later on the size grows, we will just correct it again. So let's go back to, let me go back to the, right here, this one. Here, we're doing a C out, and then why is this one called there? Let me save it. Oh, not C out, STD. Somebody should have corrected me there. Sometimes I say something and then I write another thing. So that is going to take care of it, and then we compile it now, and it should give us the last character of both. So Mausa has A, and then this one has A. So let's just change this one to 1Z, and even though it's A, and then this one is also A, this one is going to say size of 4, and then it's going to print an A, and then the other one. So I'm going to also give another tab here, so it will be a little bit cleaner rather than putting AA. Now we go Control S and then run it. Okay, so here you can see that it, the last element of the strings OR, it did not print it. Why did not print it? Did I just type something wrong? My cats are 4. Let me go to the terminal. Okay, and then save it one more time, and then compile it. So it is not, do you see any typo anywhere? It is printing the last elements OR, but it's not doing this last element anymore. So let me just change this one to double quote, and then /t, and that should have still address it. Something is wrong. So the way you know what is wrong is go to the terminal. The name of the program is my C string there. So I'm going to do a directory my_C string.c++. It is there. And now I'm going to just generate it using the command line, compile it and say g++ -o my_C string.exec, and then my_C string.c++. That's the compilation. If compilation errors out, that would be a problem. Right now, it is not erroring out. So I'm going to say my C string.exec to run it. And it does print out the A, the last element of the strings OR. It only printed out only one of them. So Mausa, and then the second one is 4. So why it did not do the 4? Because this one was, you see that it is 4. So the fourth element in this case is a problem. You cannot hard code this a number here and say that when your character is not 5 characters, you're assuming that this one is there. So instead of this, you could say whatever is the string length of my cat 1, then you subtract 1 from it, -1. And then that would be the actual size. Here, the same thing. You just say whatever the string name is called a string length times my cat 2, and then is the string, and then -1, that would be there, and take the G out here for the string, and that take care of that. Save it. Save it and then compile it and rerun it. And let's just look at the output again. Here, I'm going to clear this, actually not clear the screen. Let's just recompile it and then rerun it. And now this time we get A and A, because this one has an A and this one has A. So no matter how many characters I remove, if I remove this character, let's say on this character I remove it out, and then this character I remove two of them. So the name of is let's just call it Mo or Meow, Meow or something. So the next one is Semp, and so this one is having 4 characters, and the last character is O. This one is 4 characters, the last character is B. Now I run the same code here. Let's save it first. So now notice that the meow is 3 characters. Now with the null, it's going to be 4, but the null is the string length is actually 3. The null, I say that doesn't count. So it is, when you point here, it just says it's character 4 because it's a null pointer. But the actual length, when you're printing the length, it's 3. And then here, this one is 4 characters, and then the null pointer is there, it does not count. So here, notice that the last character is O, and then because of meow, and then the other one is B because of Semb. And so this is how the programming language works with dynamic functions that are based on these functions, the string length, it will automatically knows what is there. And a string length minus 1 always return the size of the string minus 1 because we start with 0. Since we start with 0, minus 1 would be pointing to the last one. 0 pointing to the O and the last one. So later on, I'll show you on the string that I'm doing some other functions to just print out or chomp some characters. And I use the word chomp because there's a function in Perl programming that uses chomp to chomp off the last the new line characters or the last characters from program. And people love it on administrative kind of work when they're dealing with those, but you can write it on the fly, these kind of things. A lot of the things that when you're becoming a developer, a lot of the things that are harder for other people to manipulate the data for you is like, well, give it to me, I'll do it now, rather than tomorrow or in an hour. You just do it at that time, and you can manipulate it. So this is neat. You have the option to do that one. Do you have any questions so far on anything that I covered? Okay, so no question, that's good. I have a lot more to cover. It's 8 o'clock. Let me just go to this one right here, and then I'm gonna go to my home directory CD, then I go to programs and then C++. So I clear my screen, PWD and ls-ld, star.c++. You can see there's a lot of them that we have done for this class. But I want to do ls-ltr star.c++. This one is showing me in timestamp and reverse order at the bottom, and then give me a long listing based on the timestamp. So the one with showing out 28, I'm going to demo some of this one this week, some of it next week, and we will finish up chapter 8. But the majority of them we will demonstrate today and Wednesday, and then we will sum up and cover up everything on next week, which is week 8, week 16. And if you have any question, we will cover up everything on the review for it. So let's just go with Well, we were discussing something with chomp. Let me see what I wrote on the chomp.c++. So this program, actually the date that I wrote is not 27, it is 28. So this one, let me just see what this one is. This one, I wrote a string demo in order to just demonstrate some of the string. This is a C++ string module. This is not a C string. So C string and a string are different. A string module on C++ was a new library or module or a class that was introduced in C++. This is more advanced, more robust in terms of functionality, in terms of ease of use, and in terms of everything that you want to do with a string. You could just include this module, and then there's a lot of libraries that are functions or predefined functions that are already included with it, and then you can just add on to it by user-defined functions in addition to what is not there by using these functions and these predefined list of functions that are member of the functions. For example, the string substring you could do. There's a string dot add there, the string dot length, and the string dot insert, the string dot erase dot empty. A lot of these ones we have it, and then there's assignment operators that you can do. For example, assignment operator. Remember earlier I was telling you that with the string, the nice thing about operator overloading, that instead of assigning a variable x to a variable y, or vice versa, or 5 to an x variable, then you can assign a string to a string. So this is assignment, or you can concatenate. This plus equal is like a string cat command on the C modules. So you can concatenate it, the content of a string 2 and a string 1. But the nice thing about this string module, when you concatenate this string, on C, you have to use a string in cat command to concatenate based on the n size. If there was no n limit function available, because the compiler, sometimes they don't support it. If the compilers are older version, they only have the string cat, but not a string n cat on the C string type. So with the introduction of string modules, now you can concatenate a number of strings, and then this destination string automatically is going to grow as if the size is dynamic. It is doesn't have to say, well, I'm only having a limitation, because when you define this object to be an instance of this class, then you are not just kind of like saying that give it this size only. You are just saying that this object is a member of this class or instance of this class. And then as a result, you are having these options of concatenation, insertion, and these other member function like a string.erase. You can say erase a string from a certain position with a certain number of length. You just want to chomp off 2 characters from the last 2 bytes of the string, or maybe 1 character, you can do that one. So this program does actually do some sort of erase on the last 2 bytes, and I'll demo those ones as an example here. But there's a lot of other functions like a string find, a string. Don't expect that every function that on every module that are there, we're going to just give an example of it. But please expect that you understand the concept and the module, the functions that we are covering, you have a good understanding of it. And if you question on it, I will explain the detail of it. We can just find out the answer to your question. But knowing one of these ones, then the 10 other ones are easy to figure out. All you have to do is make sure that you just know the prototype of the functions. The functions has a prototype, and the data type that it returns, the arguments that are passed, as long as you are matching the data type and the arguments with the same data types, the rest of them are, doesn't matter if it takes 1,000 arguments or one argument or 5 argument or none. You just look at the type of argument, that parameters that are taking, and how the data type is, and what is the return type. That's all important concept. And then sometimes understanding something in terms of details is how the details are hidden from you. The abstract layer of something is not just how people hide it, or we call it data hiding or abstraction. If I just say C++, obviously that's a programming language that you would say, but the detail is all hidden because of the syntax and semantics and functions and modules and the compilers and the source code and the binaries, the executables, or all those are the details of it. If I just say operating system like Linux or Unix, that's an abstract layer that is just saying operating system works with compilers, with application, with databases, with network, with users, with shells and everything, and then memory management, IO management, CPU management. But the top layer, as an abstract name or as a summary, you just say operating system. And a system that operates on a system that works on an operating system is kind of like a software that handles these things that we just discussed: databases, networking, software, application, users, programming languages, compilers, and other hardware resources, CPU, memory, and disk, and everything else. So let's go to the example. This one, I included the string. This is where we earlier showed you the string modules. And then here we are just defining two strings. One is called the string and the other one is called original string. The reason I said original string, because I expect the user to type in a string for me. Whatever is the string, and then I enter that string back to the user. I say, you enter the string. Normally, you see that the nice thing about this string, you don't say how many characters you're allocating, how many bytes you're reading, is it have a null pointer, none of that. All that one was taken out. The reason that C++ is an enhanced version of our super set of C is because whatever was on C, it does a little bit more than that. It comes with class, it comes with object-oriented, it comes out with these kind of libraries that have additional functionality, additional features that were missing from previous one. And if you look at Python, for example, Python is an interpreter language, but the ease of use of a programming language like Python is so kind of like friendly that you can just learn Python on a given day. I learned it really fast, maybe on one day. The entire things, and the data structure, concept, syntax, everything. The first day I read the book, I just went through the entire book and then started playing with it. That's how you should be learning these programming languages. It's not like, well, the syntax, you know it in C, and you know it in C++, and you know it in Java. Now you're learning a Python. Every chapter takes you one day. No, just take a glance about it and know that this is a programming language. Semantic and syntactically is different. Semantically is not different because it's all runtime. Syntactically is different, but the syntax can be caught easily because most of the programming language, they still have a for statement, they still have a if statement, switch. If they don't have a switch statement in Python, they use the if statement. That if statement has enough functionality to write the switch statement. For statement, do statement, for each statement, or you know, all of those ones are there. The writing functions to do subtasks and writing modules to have a combination of sub-functions. It's all just going to be intuitive. It's going to be easier. The more you work with it, the more it becomes easy, and then you could just say, well, I could just learn it in a less number of hours or less number of days than everybody else. And I'm sure you could. It's just a matter of believing in yourself and doing it, and it comes to you. And so the namespace here, we're using the standard, so we're not doing any std in front of them. Here I read the string and then I displayed it back. And then at this time, I want to save the original string, because when I do the chomping for the erase, it is in place on the string that I'm manipulating. So later on, when I want to use a string again, then it will be already, if I'm chomping it with 2 bytes here, then I'm having only, if the string is this, I'm already chomped off the is, and I only have the th. So in this case, I need to save that string into the original string. And before I do the manipulation, notice that here I save the value of the string to original string called org string. So that's org stand for original string. And then here I chomped off the 2 bytes from it first, and then I erased again after chomping off first 2 characters of the string. First, I chomped off the 2 characters from the last bytes. So here, length -2. String, whatever is the string length, -2 will give me the last 2 bytes. But then if I just take 2 bytes, the length, in this case that I want to chomp off, the string.erase has the last parameter as length. The length in this case is 2 bytes. I want to chomp off the last 2 bytes there. But in this one, I want to chomp off the first 2 bytes. So this one is at position 0. 0 meaning that in the index of 0. The whatever is the string, a string sub 0 or a string at location 0 will return that pointer. So here there's a function called string at somewhere here, right here. A string at is also, this at symbol is also in Python. There's other programming languages, they have this substrings or doing a string within a string. You just pick up certain things. So a string at, it has an index. If you put 0, it just returns the first element of the index. If you put a string length -1, then it will be just returning the last element. A string -2, the last 2 elements. Not the last 2, the last from the second last one. So here I'm going to just compile this and say G++. Let me clear my screen and say ls -ld chomp.c++. Sorry, clear screen. ls -ld chomp.c++. So if you're on Windows, notice that I type in CLS. This is would work clear screen on Windows, but on Unix it's clear. So if I type in CLS, it's not going to work. The way I would make it work for this one, I could say alias clear screen is equal clear command. Now if I say clear screen, it will work like Windows. So and the alias is your friend. You can just say alias CLS, and then it will just write that statement there. If I want to just alias at CLS, and now I just type in clear screen, it doesn't work. And then at any time I could just add that one, but I rather do the clear command. It's already there. In which clear command, it's actually which clear command, it actually shows that user ben clear is a file and that might be binary. That's why, and it's not the bin directory. Yeah, you can see it's executable link format. I said might be because some files are kind of like built in within the shell, like PWD and other ones, but sometimes you have the actual binary. It's not built in, it's another standalone binary file that you're using. So let's come back to clear the screen and then let's do chomp.c++. Sorry, I missed the O here. So chomp.c++, and then cat -n chomp.c++. You could see the files are there, and then it's too much. I'm going to just compile it. G++ -o chomp, and then the source code is chomp.c++. And then if I run it, I type in chomp, correct? So let's just write some characters. It says enter any character of this. So let's just write C++, or just like write CS no space 002. And then we just put a dash and say fundamentals of computer science. And so on computer science, and then dash I for 1. So now if we want to chomp off this one, it says S001, we wrote this one. It says after the character was there, this was the actual character after swamp. Originally, you entered this string. And now after the last two character was swamped is this. And then before, after chomping off the first two character, CS was removed here. So let's just run the same program here, say, just write hello. So here you can see hello was written, and then after chomping off the last two characters, we lost LO, and then before chomping off the first two character is HE is gone. The original characters are still stored on the original string. So if I just go back here and say vi chomp.c++, and then like I printed out here, I could print out before end of it, you say your original string, was it, what do you call it, origin string, origin, and then a string. So if I print out the original string here, we should get saying that this, and then I'm going to also put this line here in front of this, and you say, put a new line here, and you say your original string was, and then just new line character. So let's just compile it again here, and this time I'm going to do the G++ here. Here I compile it. So somehow I mistyped something here. Let's see what I did this one. /y. Okay, I missed. The reason it is giving me that error is that I meant to type in N here, and then it says, oh, you want to escape this one, but it did not understand what I wanted to do. So if I just do escape it with new line characters and then put that one, it should be okay now. So compile it and now run the same code. And this time I'm going to type in the last thing that I did, hello here, hello. And notice that this time is going to say hello after this, your original characters, but now the chomp is already chomped off. So this is just basically, since it's in place, it just loses it. So in order for me to even chomp off that one to store it, to save it for reference back, here I could just say, let's say on this one, before I use this one, I could say put this one on a string 2 and as equal original string. So the original string, before I lose it, I have it there. And this string 2 is basically another temporary location for me to do it. And then at the end, I just print the content of string 2. String 2. So here, if you look at it now, watch G++ minus O chomp, and then run it here, and I say hello, and then you can see that string 2 is now printing out my original one because I saved it. So the concept that I'm teaching you here or showing you here is that vi chomp.c++. In this string library of C++ or a string, you can use the word library, module, or function or class, and they are interchangeably used here. So let me just put a comment here. Let's put on the top of this, say when we include these modules, which is equal to libraries, which is equal to classes. We're referring to the same thing. We are referring to the same thing. So whether we call it library, module, or class, this is one library or one module or one class. This is another library or module class. This is a string is also a class in this case of this module library. So a library could include many classes or could include many classes or many other modules. And then a library or a collection could be a bigger one. So let me correct the library. I meant libraries, and then I missed the S there. Modules, libraries, and classes. So we could do this one. And similarly, so member functions is equal methods in object-oriented. So if you're talking about member functions, like for example, this string.length, this length function is a member function of this string object. This string is an instance of this string class, and this .length is a member functions or a method of this string object. So that's how you would use these ones. Okay, and then let's just we did the compilation of this already. Let me show you one more thing here. C++. Let's go to this get method. Do get line and so on, like my get line. So I'm gonna run my C code here. My xterm.sh. I will run this in order to do this. I will run xming here and then enable the x window. So now I run my xterm.sh, and it will just open up 5 different windows, which is on the background here. And then let's just make one of them bigger. I'm going to use this one for today since it's in the front. It went and the lotto. It showed up first. And so here I'm going to do the same thing, ls minus ltr star.c++. And I showed you that I'm going to do the my get line.c++. So vi my get line.c++. Get line in lowercase is a method that actually is used within this C string modules. So in this case, it's a very simple method. I'm just using array of line, which is 80 characters long. And then I say enter a line of text and press enter when you're done. So it reads the line of text from the console n. And this one is console input. Console n dot get line. Get line is a member functions of this instance of CN object. So get line is a member, a method or member functions of this CN object. In this case, it takes 3 arguments. You can pass on 2 arguments, but if you pass on 3 arguments, the first argument is the stream that is going to be reading from. In this case, the line, which is a string, is going to be read from the console input, which is from the terminal. It is asking me to input at the terminal. But if I put it from a file form in a stream like we did on chapter 6, then this would be the end file stream that you're going to do it for the get line. And then if it was from out file that you're producing it, normally on out file you're writing, not getting input from it. So it would be always in file or in from console. And then the size, and then the new line character saying that once the %enter is happening at the end of each line, there's an end of line marker that determines that one. Once that one is done, then it is going to say, you enter this string, and then it's gonna put the string name and then the length of the string. So the string is right here saved in this line because we have it as an array of that pointer. Let's just compile that one and we say clear screen, ls minus l something get a line something.c++. So I call it my get line.c++. I already compiled it, but I'm going to do it again. I'm going to rm this file, my get line there, and then rm do get line. So we only have do get line. I just have to put uppercase L here. So we have only these 2 program now. Do get line, and now I'm gonna compile the my get line, and then I wanna execute, compile that one and generate a my get line like this name as executable. Can somebody volunteer and give me the syntax for compilation of that one, please? It's a G++, and then, so I put one argument, -0 for output. And now what do I give the name of the output? I want to give it output that is here, my get line, right? And then the source name, and the source name is this .c++. So it compiled successfully because echo $? meaning it is good. Now if I do ls minus ld, I have one more executable file here. And if I just say file my get line star, then it shows that my get line is a executable link format, a shared object, and this and that. So all of that is detail is there. The my get line.c++ is source code ASCII text. So now I'm going to run the my get line, and then it says enter a text and press enter when you're done. So I want to say hello. So let's do that, and then just says that okay, you entered hello at, and then whatever put the word that I put, it just does that and then display it. I'm going to clear the screen and run the program again. I say CS002 fundamentals of computer science 1. So it says you entered CS002 fundamental of computer science 1. The string length is 41. How nice is that? I mean, it's dynamic. If I say this, that's 4 characters, and it says that string length is 4 characters. And so it echoes back exactly what I wanted to say. If I just say, hello, CS002 students, it just says exactly the number of characters there. My get line is for all. It is the same thing. I love to play football. So you could just see the number of characters, everything. So that my get line, my get line.c++ is the source code. Only a few lines of code, but it echoes anything that you want to do and on the screen and it displays. But it has a limitation of size 80 characters. It reads only 8 characters, 79 characters from 0 to 79. The last one is 79, so it's 80 characters long altogether. And then if I just want a larger ones, obviously I have to compile it with this size to a larger 255, 1024. You could read an entire book by giving it a bigger size here. So let's just do this. The next one is, I think it's called do while, do get line. So this clear screen do get line.c++. And I'm going to do vim on do get line first to show you the content of this one. And then I set a number on so you can have line numbers, 23 lines of code. And what I'm doing on this one, it reads up to 255 characters from the standard input, which is the console, and echo it back along with the string length. This is similarly with other ones, but and the way this one does is it read the number of characters and then the max characters defined here, and instead of pass on into the content as a number. Here it is a constant. Whatever you change a constant number to 80 to 255, 40, 96, 4K, or whatever size you could do, you just allocate it based on that, it will read it. But notice that instead of new line character, I'm expecting a Q for quit. So if somebody write 80 lines, 80 characters and then wants to quit, they have a choice. If they want to write 2 characters, it would still do a quit, they have a choice. On the previous one, it was the limitation of 80 or new line characters. Here, you could type in 1 character and press a new line or type in Q. And then the string length is done. So the same thing, very easily. I'm going to quit out of this and then say G++. I'm not going to compile it. I need somebody to help me out. How do I compile this one, please? Somebody volunteer, tell me the syntax. I need at least 1 or 2 volunteers, please. Hello? How do I compile this program? Okay, if I don't hear anybody. Okay, go ahead, please.
Is it G++ and then do get line.cpp?
Do get line, yeah, .cpp, and then?
we do?
You have to generate an output file, right? So to generate the output file, you put -o for -output file, and then you gave a name of the output file, do get line. And thank you so much. That's all it needs. So it needs a source code. The argument, whether you put -o first and then the executable name, followed by the name of the source code, or you put the source code first, followed by the -o do get. The parameters are very understood at the command line syntax on the G++. So wherever you put the order is not important. The important thing is that -o option, it will read this source code, do get line.c++, and then try to first compile it. If the compilation is successful, no syntax errors or anything, then it's gonna use the linker to, with the preprocessors that you included, all of that one to just include the modules and libraries together and link it and generate this executable file out of those intermediate files that are there. So, and then it's going to generate this one. So this -o is compile plus link. If you do -c, it only compiles it. It does not generate the executable. If you do -i for intermediate file, you do it. If you do -s for assembly line code, all of those ones, they have different syntax. But -o is compile plus linker. So this one will just generate it. Now we generated this get line. Sorry, this -l and do get line. And then you can see that now this one is as of now 2039, 2038. It was just happening on November 29. We just created. In order to run this one, do get line. In Unix, if you put // it runs it, since this is an executable file. How do I know this is executable? Is because on Linux, it changes the color, and also it has this read-write execute for the owner, read-write execute for group, and read and execute for other people. This X meaning that it is executable file. So what does that mean is an executable file? This means that the binary that are there, the assembly code and the executable code is already in this name. If I just do a file on do get line, you can see it shows that do get line is a ELF, executable link format, 64-bit, LS shared object. It's a platform x64. And then all of that dynamic link library. So some of the link libraries that are there at the time that we give this option -o option, it actually uses all these uses LD for linker. It actually compile with this shared object file. Linux x86 64-bit .so. .so meaning shared object. Shared object, this is by itself is a library. So if I do ls -ld and this file, this is the file that at the time that we actually left 64/Linux-x86-64.so.2. You can see that this file was actually already there, and then this shared object was for the linking and loader, it was used. And the way I know the detail of that one on the system, if you do LDD, this one is say statically linked. So this shared object file is statically linked, is meaning that the standard C libraries are actually attached to it statically. It is not just at compile time is there. It's actually will be statically available there. all the time. Even though it's shared object, and the shared object normally, or the libraries are automatically at runtime will include. So the libraries are doing this, but now if I do LDD on my do get line, you can see that my do get line, it uses, in addition to this statically shared object, it uses some other libraries like libgcc, math module, C modules, standard C++ modules, and all of that one is basically, or at compile time, they're just going to be shared object that are included. So user lib x86 underscore 64 dash Linux dash GNU and dash lib standard C++. I'm going to put .so.6. And then you can see that one is also, in addition to one was statically, these other ones are dynamically. So it gets linked. At runtime, when I run my do get line, whatever library functions that I did not define it and I wanted to include it at, by using the include directive with the preprocessor, because of this shared object, it will be available for me. It's shared object or shared library object file. Do get line. And then it says, please enter text and press enter Q. So I say hello here, and then as soon as I type Q, it will just say, okay, you wanted to exit. And now if I just run the same thing, I type 1Q, notice that I did not give any character here. And it says Q. If I just enter this and I say A, and then followed by a Q, notice it says that you press A and then you give a space. So the characters are 2. If I just do AQ, and now it says the size of my character is 1, because the quit is just on the get line. I wanted to quit as soon as I wanted to. So if I just do more characters, say, and this is a test and I like to type more. Let's say I just do that one, and then I go, and now I am on the next line, and I'm going to press a tab, and then I tap and say, and now let's go to another line, and then another line, and it goes, keep going, either to match out the maximum number of characters that I do, or see a queue. Once I type in a queue, it says, oh, you entered altogether 135 characters, and these are your characters. So it does similar to like a reading from the console. If you're familiar with cat command on Unix, it does exactly what this do get does. So let me demonstrate a do cat command. Cat command, it concatenates in addition to concatenate files. So like, for example, cat do get line.c++, sorry, do, I just typed in one character here, a typo, okay. So if I just want to see the contents of this file, it concatenate for me. But if I want to do what I did with the do get line method, to say concatenate it, not from a file, but from the standard input, then I could just say cat dash here and just say this is a test. And it just says, hello, my name is Wahid Lutfi. I love to play soccer and play with C++ and Python and Unix, Linux environment. So you could type in and it just keeps echoing for you. And if I say Control D, it just exit out. I just did that one. That is basically the other thing that with the get line. If you want to just terminate it, you could do Control D. And you could also do like cat this and say this is for sending like to a shell script and then send it to say, now whatever I'm typing in, it should execute these commands. So now let's say I say cat this and then say s1 dot bash. So I could just create a file called s1.bash. Inside here, I could put any command. If I put it inside the backtick, pwd, for example, and then backtick and say who command, and then backtick host name information, and backtick date command. And then I could also do the $sign and this, and then the command inside the $sign, like $sign, and then say cat, what is the name of the file called, and do get line.c++. So we could just content of that file. And then we could even do like cat change mode 755 s1.bash. So we could just say that once you do this one, it's there. So now I put all these commands here, and then within this cat command, notice how much functionality they give you. So SS is meaning that shell script. I just say, let's start with this one until I don't put that SS. It's like almost our Q command that I just showed you on the do get method. So this one, whatever I define here, I close it with that one. Now, this is like a dock screen. Now I have this s1.bash because all the command worked, and then this chomp command even worked. So now my cat minus n s1.bash, it just have the output of all the commands that are there. You can see that is there. So I could have named it s1.bash.output or s1.output. And then if I just do a more on it, you can see for each of those commands that I did, it just says the print working directory, the output of the who command, the output of the host name, the output of the calendar command, the output of my program get do line screen, and then finish. When I was saying earlier that you can do by learning one thing, you can just attach it to another one, This is how it works. Computer science is very easy if you are just kind of in the right track and following the right path and taking the right courses. Don't jump from classes to classes and finish one halfway and do the other one. So make sure that whatever programming languages that you're taking, whatever operating systems you are taking, make sure you understand them. Make sure you ask questions from your instructor and then follow up for your next class, because each one of them is a steps that you're going from one step to the next step, and all of a sudden you're on the top of the ladder. Okay, let's see what time it is. It's 8:50. I'm going to do a quick demo of Victor. Let's see what else I have here for you. I'm going to use a different screen here. Let's do this screen. That was second. And I like to just change it, the interface a little bit. It is looking better when you do different examples with different things. Let's minus LTR star.c++. So the chomp we did, and this we did. Now let's do the C string demo. Let's do the C string demo also. And then we did a string demo already, I believe. The C string demo, I'm going to do string demo.c++, and then the vector, we can do it on Wednesday if you want. So here on this example, what I'm doing is to demonstrate the C string. Again, the C string is having a null character at the end of the character. So in this case, the character is the string is cat, and then the null terminator is /0, backward slash, and then fruit is the name of the fruits, and then apple, string, pears, and everything. So you could see that a string copy, you're copying into apple to this and this and that. But the problem with this kind of information, sometimes because string characters or string characters or just basically read-only like Python, you can do this kind of assignment statement with a string copy to something like just copy one to the other one. And if you are able to do it, yeah, that's good. You could just put into a string apple to fruit and then do the same thing, but not to the ith element of it. And then the I element of it is sometimes is just one character. You cannot take the whole string to put this one. So this is a no there. And the option that I showed you last time with let me just show you another one. Right here, this let's just do this WL underscore man dot C++. So here, as you can see, I just I'm copying into this my command and the manual pages. So whatever is the command, I concatenate copy and the string man to it, and then at the same time as I concatenate using cat command, string cat, and then at the same time, whatever is the argument sub b 1 or 2 and 3 is passed on, depending on the number of arguments passed on to the command line. So argc has the total number of commands that are passed. So I'm going through a for statement within the argv sub 0, so argc, and then I put argv sub 1, sub 2, sub 3, and concatenate it to them. But in here, I have a limited size of my command to be 50 characters long. So if I just compile this one and say g plus plus minus o, and then wl underscore man, and call it wl underscore man dot C++. Now I compile it and I just say wl underscore man, and so I want to get the manual pages for just say cat command itself. If I do that one, it just displays the cat command here. If I just want to do same thing with instead of this, say for the PWD, or get the command for system and D, it will just give you the information here, there. And if you want minus S3 for section 3 of a string, then you will get that same thing. Earlier we were doing the man pages, so now you can do the WL underscore man, which is my program that does a system call to C, and the function that I'm using is a string cat and a string copy and of C type along with the system. So the system itself, more WL underscore man on both Python and C and C++, the system is doing these kind of functions calls there. So C++, notice here, I have string cat and everything. At the end, I pass in the argument, my command to the system function calls. And the system is defined on the C standard methodology. Okay. And just since we're talking about the system calls, and I will just run this man page with a number of other arguments. Let's say I go say, okay, find me the scanf argument. You could get it. If you just say, find me the printf statement, I'm going to give you. If you want to say section 1, or let's say section 2, the function read, it is automatically just says find section 2 of the function read. If you don't give argument to it, the command is still smart enough to say, well, manual pages automatically sees that one. So if I say man minus k, and then I say read, let's say, it just does a man minus k read like this. And if I do the same thing with my program, say minus k, and then say a string, all the functions that are related to string, and then same thing with vector. If there's anything, we'll just display with vector. So, and then let's just do one more of minus section 1, and then say the who command. It just does that. And if you just don't give the section 1 command itself, it just knows that who is in section 1. It finds it. So while we're talking about the system and C++, I want to just do one more thing with Python using the system functions. So in Python, if I clear my screen, remember, I'm comparing this one because you're in computer science and then you're taking the first class, and the next class might be your Python class. So let me just introduce you to same kind of concept with Python. If you look at Python, if I say which Python, it is there, and user ben Python -v, it says that I'm using 3.8 there. Last week, I believe I just changed my Python alias to point to 3.8. That's why this one is there. In addition, on user ben Python, I mentioned that I get rid of the 2.7 symbolic link from this Python, and I pointed to Python 3.8. So whenever I type Python itself, it just goes to a 3.8. Whether I put Python 3.8 or I put Python or user ben Python or user ben Python, automatically knows that I'm using Python, which is pointing to this binary, and that binary is right here, and it is executable. So at this time it's 3.8, and then if I just do import OS, this modular and Python is operating system. You say import OS, if I type in dir OS, it gave me a directory of all the libraries and functions, predefined functions, and methods that are available for it. So one of these library function is called system. There's a lot of other ones that you could look at it, like make dir, make open, and this and that. So a lot of them are there. So at this time, I'm going to say, let's just run a Unix command to just get a list of all the files that are on that directory from within Python. You say os.system, and then here, within this one, you say ls-ld start.c++. So this one will just give a list of all the files there. And now if I just say, okay, they just did that one, ls-ld, let's look at the words.c++. So that file is there. If I want to concatenate it, I could just do the same thing. If I want to run my program, we call it wl_man, we just want to do that one. And then let's say, since this is not in a binary path, we might have to put certain ways to run it, but let's do it the regular one. At this time, I want to say, just give me a man page of the calendar. So it says command not found because this one is on the subdirectory that is there. And then if I just put from that directory that I start with, it knows, okay, that's the command. So right here, if I just do any command now, say who, it will just give me the output of that. And similarly, if I just say clear my screen here, clear screen, and it just does that command. And then you type in here uname -a, it gives you the OS now. Cut etc os-release, everything is just there for you. And then if you are done with it, you just exit out. And that's how you use OS system calls within Python. And we already showed you in C, using the C string libraries as well as the C standard lib system functions. That was there. Okay, I believe it's 9:02. I'm going to stop it at this time, and then we take a break, and then let me just stop the recording first. You can take a 15 minutes break, and when we come back, basically, we're going to resume on the break on the lab activities, actually. Hello, student. I'd like to show you one more examples of the C string and then the module C, the module string on C++. So let me just share my screen here with you, and I'm gonna do two scripts here. So let me just do a tail -4. The example that I want to show you is the C string, and then also the demo string. The C string is C style string function, which does some functions here. Let me VI this one first and show you. I prefer the usage of the demo string.c++, which uses the C++ string module. So let me just do this one first, string demo.c++. If I open up here on the comments section, I put that use the C++ string module functions instead, that use a string module and the predefined function for the string module. And the example I'm providing you is demo string.c++, which I'll show you after this. But pay attention to this one first, because here we're just trying to declare using the character array using C string module. So we are creating a character array with a string cat, each of them being a single character, C, A, and T, and a null pointer because of the C type of string characters. And then at the same time, we're declaring a fruit character with 50 characters long. Originally, we started off with a string copy command to copy the word, the fruit apple into the string fruit. So in this case, this will be added to the fruit with the first element of it, and then it's going to be 6 character long. And then we're going to concatenate this pair with a space in front of it with this word pair. And same thing, we concatenate grape and we concatenate banana. So we make a long list of fruit names. We can concatenate as many as we want, but in this case, I'm doing it 4 of them. So here, this 4 statements, the for statement is unnecessary because we're just doing this thing anyway. So let me just go ahead, remove this one. We are not needing it because we're not using any I initialization. So this is how, this is one function called, the second function, third function, fourth function called, by passing those ones. The reason I suggest the C++ method of string module because that one has a lot more functionality, less limitation. This one, yeah, it does a lot of things with those functions. That's why C++ was written in C. And in some ways, C is mother of all languages. But again, there's a lot of enhancement with C that came with C++. Tried to use the new feature of C++. That's why I suggest using string modules of C++ instead of doing this. So now we did this one, and then we want to show the concatenation output here with the size of it, and print each one of them character by characters for each of those strings that we copied for. So if I just compile it, let me clear my screen here, and I do C string and demo.c++. I'm going to compile it G++ minus O C string demo, and then the source code is C string demo.c++. So now it compiled successfully. I'm going to run it by putting // C string demo, and it will just print out cat, and it tells the size of the cat is 3 characters, which is true. Then it puts each character as a fruit sub I being A, and then P, and P for apple, and then a space, then pear, then a space, then grape, then this, and then concatenate the whole thing within one single code to say this is the entire fruit list, and this is 23 characters long. So you could do this one. In addition, the easier way to do this one is a demo string.c++. So let me VI that one, demo string.c++. And as you can see, this one is shorter number of programs the way you write it. Basically, if you want to do a cat, yes, you do this one. You don't need a null pointer to terminate it. The string automatically just knows that this one is end of this last character is null pointer. It's assumed. So then the next one, you can create a string of fruits, and as many elements you want, you can just initialize it like a list similar to Python, except that Python, instead of the braces, you use brackets, and then you just declare it similarly. But obviously the name, you don't need to do the data type, you just give the name without the array here, and then this array structure is only on C and C++. So not on Python. And the Python, you just put in this within brackets, and that's your list. See out right here, it is just going to print out the actual string. And then the second one is, if I want to get the size of it, the size of it is the string length, basically. A string length in C string is changed to size. Yeah, they every time they compile it, they just want to make it harder to memorize a different function name for same thing. They could just have called it string length, but it would be like, well, maybe they cheated or something. I don't know why they just want to make different names for something that is much easier to convert it. Yeah, there's some compatibility issues. Some people say, well, I use the string length, it is there, defined, but maybe it does differently here. So for int I is equal 0 cat size, here we're printing each element of the string. So notice that this one, fruit sub I, will be like whatever is this one, apple. Fruit sub I 0 would be apple, fruit sub I 1 being pear, 2 would be grape, and 3 would be banana. And that's why whatever is the size is 4, less than 4 is 3, so fruit sub I 3 will be returning banana. And now if I just compile it, G++ minus O, demo string.c++, actually demos, and then demo string.c++ as source code. It compiled, and now I'm going to run it. Demo string, And you can see that the size of the string is cat, the length of it's 3, and apple, pear, grapes. Again, if I just want to know for each string, I can even just print that out each string. Now I have more control. So let's just VI one more time here. As we are doing it, we could just say less than sign and then say fruit sub I dot size of. So let's just see if we could get for each element the same things with the length of it. But again, here I want to just tab it a little bit so we could have a space there with tabs, separated by tabs in between the two. And that's how you do that. So let's compile it again, and it ran fine. Now we're going to run it right here. And then you can see now this time is the length is 3. For apple is 5 characters, pear is 4 characters, and grapes 5 characters. And that's how you just get the entire thing. And then if you want to get the capacity, and other ones is similar. And the size of is going to give you the total storage. And then also the, let's just do the size of also, I want to show you one thing. And then do minus O, VI. Right here, I'm going to do also, just print out the size of this cat.size of. This would be the storage, and then similarly we want to get the storage or capacity. Capacity as a method of vector also. So we could just also here change it to the storage. The storage or size of is different than size. Size is just return the string length, the length of the string. Size of, it's just going to return the storage, how many bytes it takes for this storage to just be taking a space. So now size of is not recognized here. Size of and the storage capacity, string size of, and size of is might be just a function of vector only, a variable of vector, not a string. So a string might not have a module. How do I find out that one? I could go user include, and then say find dot minus name star minus exact grep minus I size of, and then use that size of. Unfortunately, this is a bigger list. It will just go so much. What you could do is to say, and just only on the string. And then the string doesn't have the size of function. It does have size, but it does not size of. So that's why. And I believe it is 10:04 and 10:05. I'm going to stop here, and then we will resume the rest of it on Wednesday. Let me stop sharing and actually stop recording first.